Okay, for your question 12A, it is about kinematics. And this kinematics is a super easy question. So in your 2021, I think it will be a harder one with your VT graph and things like that. So let's try, okay? So I have basically this object that move along this very weird path. And they're asking you to find displacement. So displacement, like I said, it is just final position minus the initial. So this is my starting position, this is my end position. So what is the displacement? It will be 20 plus 20 plus 15 plus 10 plus 10. Okay, you go and work it out. Remember 2SF. Then the next question, they are saying that the object move at constant speed along a circular path, and they are asking you if it is accelerating. So first thing you need to know is what is accelerating. Accelerating means there is a change in velocity over time, right? And you should also know that velocity consists of two parts, the speed itself and the direction. So if there is no change in speed, you still need to check if there is a direction change or not. So when you are moving in a circular path, are you changing direction? So let's say you are on a circular path. First, your direction is like that. Then your direction is like this. Finally, your direction like that. So do you have a direction change? Yes, you have. And so if there is a directional change, that means your velocity is changing. So if your velocity is changing, it is accelerating. It will be accelerating. So as a result, the answer for this is that it is yes. Okay, and you need to explain it is accelerating because the direction of the object changes as it moves along a circular path. So if you have already occupied two lines, it means that it is sufficient. But what if they give you like a third line? If they give you a third line, then maybe you need to explain further lah. When it is keep on changing direction, then there will be a change in velocity. When there's a change of velocity, then there will be acceleration. Okay? Okay, for part B, difference between speed and velocity, it is a giveaway one. There are many differences. One is scalar, one is vector. One has positive and negative, the other one don't have. Okay, go and read about the textbook. Our textbook got a lot. Okay. Okay, for part C, like I said, I always like to put all the values into the diagram so that it is easy to see. So I know that at position P, it is time equals to 0. And I know that after 40 seconds, it's going to reach Q. So I put it there as well. Down here, it says uniform speed. So I write down here, acceleration is 0. They tell you the speed, so it is already here. Then after that, it says it changes direction. That's why it is another diagram towards P, right? And then it says that it slows down uniformly. So what it means by slow down? Slow down means that it is deceleration, right? Okay. What is the meaning of uniformly? Well, if it is uniformly, then it means that this deceleration is constant. And what does a constant deceleration mean? Well, it means that I would expect a negative gradient on my VT graph, right? And this negative gradient will be a constant one, meaning that I'm going to get something like this lah. Okay, so that appears in my mind. Then I would know that it comes to rest in the next 20 seconds. So I am at 40 over here. That means by t equals to 60, I should write my thing over here. When t equals to 60, I should come to rest, right? It says come to rest. So this is how I get all my value. So once I have all my value, here it says that I have to sketch the speed time graph. So well, speed time graph, right? What I like to do is I will always draw like that. So at time equals to 0, I already know that it is 2.5, right? So I write down here 2.5. Then I know that at time equals to 40, which is here, right? My speed is still 2.5. Why? Because here it says acceleration 0 ma. Okay, so I will write down here, from here to here, acceleration is 0. So v is the same. After that, it changes direction, right? So it changes direction. So I would assume that it is at the same time, but now I change direction, right? So I use negative. Then after that, it will drop speed. So it will drop velocity. So I know that it will drop to 0 in another 20 seconds, so it's 60. So with all this, now I can do my graph, right? I'm at 0, so I know that it will be at, so remember all these things you must sketch, 2.5. So I have a point here. So this one done. Time equals to 40, I will have 2.5 still, so 2.5. So I have a point here. So I done this. Then after that, 40 minus 2.5, but this is speed. So speed, there's no minus 2.5. It will be still, speed will become 2.5. Okay, then after that, at 60, velocity is 0. So I have this. Then I need to ask myself, between all these dots, right, this cross, right, are they straight line or curve? So I know here, from time equals to 0 and time equals to 40, acceleration is 0, meaning that it is constant speed, like that. Then after that, here I've already worked out, right, when they say slow down uniformly, it means constant deceleration. So it means my gradient is a straight line. So like that, no? Is it very hard? 2 marks, just like that, right? Then they ask you to calculate the distance traveled in 60 seconds. Please, this formula will no longer work. This one cannot work already because your speed is no longer constant. So how do you find distance? Area under this entire graph, which is a trapezium. So you already know a lot of things, right? Bottom length 60, top length 40, the height over here 2.5, right? So you can actually find out. Remember 2SF. Last, they are asking you for velocity time graph, and we are ready for it, right? Because we actually have, when we do this table, it is already velocity time graph. So I can go here and then I can paste this, and I just need to drag it down. Right, so time is 0, velocity 2.5, here, done. 40, 2.5, 40, 2.5, right? Done. Then after that, it changed direction. 40 minus 2.5, 60, 0, right? So I have this. So very easy to draw. Just link them up. Done already? Yeah, finish. Just like that. Okay. You may ask me, teacher, how come it's not negative gradient already? Don't worry. Okay. Because slowing down means what? This is positive gradient, right? But your velocity is negative, right? Remember in your worksheet, if A is positive, V is negative, it means what? It means it is slowing down. See? Everything checks out.